it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Hey folks, it's Stephen here with Studyclix, and in this video we're talking about the fundamental principle of counting. Now look, that's a big fancy name for something that's going to be really simple. Basically what we're going to be doing is finding out how many outcomes there are from certain events here. So let's take a look at the definition of the fundamental principle of counting. It says if one event has X possible outcomes and another has Y possible outcomes, then the number of ways that both events can occur is X times Y. So basically we take the number of ways the first event can happen and multiply it by the number of ways the second event can happen. So let's take a look at a load of examples here to see this in action. I'm told a restaurant offers 5 starters, 6 mains and 3 desserts. How many 3-course meals are possible? Now look, there's loads of ways you can think about this. For example, you could draw some sort of a diagram to try to see, okay, there's 5 starters. Each of those starters has 6 mains. And you could kind of draw out your diagram from there. And then each of those mains will have 3 desserts. But I hope you can see that this is going to get really big and really busy very, very fast. And we don't really care what it looks like. We just care to know what is the answer. How many outcomes are there? So this is where we're going to use the fundamental principle of counting. Basically, the first event has 5 starters. So I'm going to say I'll take the 5 starters. And then the second event is the main courses that has 6 options. I'm going to multiply it by 6. And we're going to include a third event in there of the desserts. So that's going to be times by 3. So all I do is multiply the numbers here to get 90. So altogether there are 90 different 3-course meals a person could order from this menu. Next up, I'm told Clix Cafe offers 7 different hot drinks in 3 sizes with an option of 11 syrups. How many drink orders are possible? So all we're going to be doing here, folks, is multiplying the number of possibilities for each event. So I'm taking the 7 drinks. Each of those 7 drinks has 3 possible sizes times by 3 and can have 11 possible syrups. And altogether, when I do that, I get 231 possible drinks. And I'm always amazed by the size of these numbers. Like if you go into a cafe to order a coffee, you don't think there's going to be like 231 different options to make. I find it mesmerizing. Next up, I'm told a new phone has 2 screen sizes, 4 storage options, and is available in 6 different colors. Find the total number of options. So what we're going to do is we're going to multiply the number of each event. So I'm going to say that there's 2 sizes, times that by the 4 storage options, times that by the 6 different colors. Doing that, there's 48 different phones you can get there. Next up, I'm told a coin is tossed 4 times and the outcome is recorded. For example, heads, tails is a possible outcome. So H and T for heads and tails. How many outcomes are possible? Okay, so we're doing this 4 times, so there's 4 events. The first event has 2 outcomes, a heads or a tails, so I'm putting 2. Then I'm multiplying that by the next event, which I'm tossing a coin, so there's 2 options again. And I'm doing it 4 times, so I'm going to multiply 2 by itself 4 times here. Why are there 4 2s? Well, there's 4 events, there's 4 times we're tossing the coin. And why am I using the number 2? There's 2 possibilities, a heads or a tails. Now I'm just going to show you here, instead of putting a big long thing like that in your calculator, I can write that as 2 to the power of 4. I hope you'll agree. And when I throw that into my calculator, I get an answer of 16. So there's 16 outcomes. Next, we'll look to part B. I'm told if the coin is tossed 6 times, how many outcomes are there? So now I'm going to be tossing this coin 6 times instead of 4. So I'm going to have 6 numbers down. And there's 2 options for each. So it's going to be 2 by 2 by 2 by 2 by 2 by 2 again 6 times. Or we could just simply write 2 to the power of 6. And when I work that out, I get 64. So there's 64 possible outcomes here. Last up, we're talking about traffic lights. So we're saying traffic lights can be either green, amber or red. While driving through 5 different sets of lights, Eve met the light sequence green, green, red, amber, green. So G for green, R for red and A for amber. Part A says how many possible light combinations could Eve have met? So let's have a think here. She's driving through 5 sets of lights. In the first set, there was 3 possible lights she could have faced. In the second set, there was 3 possible lights she could have faced. In the third set, it's 3. In the fourth set, it's 3. And the fifth set, it's 3. So it's 3 by 3 by 3 by 3 by 3, which we know could be written as 3 to the power of 5. And working that out, I'm getting a possibility of 243 combinations. So a huge number of different sequences you could meet there in 5 sets of traffic lights. Looking to part B, I'm told if Eve drives through 3 sets of traffic lights, how many light combinations are possible? So she meets the first set of lights, there's 3 options. The second set of lights, there's 3 options. And the third set of light, there's 3 options. So it's 3 by 3 by 3, which we know can be written as 3 cubed, which is going to be 27. And moving on to part C, I'm told if Eve drives through 8 sets of traffic lights, how many light combinations are possible? So what I'll be doing is I'll be multiplying 3 by itself 8 times here. Why 8 times? There's 8 events, there's 8 sets of lights, each with 3 possible colours. And in my calculator, I'll simply throw that in as 3 to the power of 8, which gives me a whopping 6,561 possible light combinations through those 8 sets of lights. Overall, folks, that's all there is to the fundamental principle of counting. Essentially, you multiply the number of options for each event to get the combined events at the end. Really handy. And now it's your turn to try this out. Pause the video here, try these questions, and check in with the solutions when they appear on screen. In 1 and 2, we simply just multiply the number of options for each event. And here in question 3, part B might have been a bit busier. We had to consider the size, we had to consider the 2 scoops of ice cream, so we multiply by 12 twice there, and we have the 10 different toppings 3 times for the 3 sets of toppings. Thanks for watching.